My first slide is that. Because look, I've been doing this for 28 years of rowing. I loved every year of it. But I start to feel, as you get more and more through your career, like, do you still feel that way every day when you wake up when I think about math? Okay? Most of you probably don't, but I do. Every single day, I'm still joyous to teach math. But I realize that's probably not the norm. I visit classrooms all over the state and all over the country, and that's not always the norm, and it worries me. It really worries me. I see too much of this, which to me is not joyous, okay? And it worries me because, I have my wife right now going around the schools right now, all your schools tearing down those posters, okay? Because it's not joyous at all, and what I mean by that, is just do this math problem with me. And show me why, and try to understand why it's not joyous. Joe has 17 skills, which is 12 fewer than Mary. How many skills does Mary have? Second grade, give me an answer, 5 seconds. What's the answer?
29.
5, right? 5's the right answer. 5, right? 17 minus 12, 5, right? No. Why are you saying no? What's the answer? Yeah, Lynn says 29. Okay, 29. I got it. 17 skills, 12 fewer than Mary. 29 is right. Okay. But let's use the poster. Very joyous. First, we'll get a lot of joy of circling the numbers. We'll get out blue crayon, yellow crayon. And then we'll underline some stuff. Right? That's good. That's very joyous. All right, and we will box something. Yes, that's cool. Good stuff. And then we'll go to another poster over here. Over there, see it? And what's fewer mean on that poster? Subtract, yes, subtract, fewer, subtract. 17 minus 12, yeah, right. Yeah. Told me the answer was 29. Not only does it take all the joy out of math, it gets the wrong damn answer. Worries me. I was at a school yesterday. I will not name this school yesterday. I'm in a 5th grade classroom. I see this poster. I immediately take a picture of it. The teacher goes, "Why are you taking a picture of this?" I'm like, "I can't tell you." Right? This is what I call math by Pinterest. You download some stuff off the internet, or math by teacher pay teacher. Here's the other thing that I do when I go to your classrooms. Most of you don't know this. When I go to your classrooms, I usually will go to your computer when you're not looking, pull up Chrome, and type in the letter T. It will come up on 100% of teachers' computers. Teachers pay teachers. And I think about that deeply because I'm an author. I think about that. Why does every single teacher in the world spend their own money on teachers pay teachers? Are textbooks that bad?
Yeah.
Do we not give you what you need? And I worry about that. I say I have to do a better job if you keep paying your own money on teachers pay teachers. I think it's my fault. And I think about that deeply, that we're doing this to kids. Those McDonald's sell goddamn cheeseburgers to teach long division. That poster's in every 4th and 5th grade classroom in the country. And it scares me. It's certainly not joyous, right? Furthermore, pedagogy. How joyous is that? I don't know where my video guy is, but I'm going to try to show a video right now. Give me just a second. Pedagogy, when I visit classrooms, is this. Spell out every single step. Students take notes or slop, okay? And then they practice. Very joyous. Very, very joyous. I'm going to show you a video of what I think is a very joyous teaching here. This is a chef, teacher, right? Chef, teacher. And he's going to make a recipe for you. So can you, what am I doing? What am I doing? He's pointing. He's pointing to tell me to do something. Right? What are you telling me to do? Unhook? Okay. Okay, oh, you're trying to time this up. I got it. All right. So there's going to be a commercial first, though.
Yeah.
All right, I'm hitting start. No sound. No, ain't sound back there. No. He's telling us how to make a 3-cheese blend. First, you start with the first cheese. Okay. 3-cheese blend, this is how you make it. You put the first cheese in the bowl. You put the second cheese in the bowl. And you put the third cheese in the bowl and you mix them up. This is how you make a 3-cheese blend. Sounds like exactly how we teach mathematics. And we're done. That's it. Now, the narration of that was pretty bad. Sorry there wasn't any sound. But what's better is the comments after you watch that video. Because you know what the internet does. Slow down. You didn't show us how to make a 2-cheese blend. Flying a jet is easier than this. I want to make a 4-cheese blend. Could you make me a video? Can I download a step-by-step PDF somewhere? What happens if you reverse the orders of the cheese? Okay, tell me some days when you're up there teaching something and you just taught it and the kid says, I have no idea what to do, you don't feel like that. Okay? And I say it's because there's no joy in pedagogy. So, can we bring some joy to mathematics? So I'm going to try and do 3 or 4 things that try to bring some joy. Okay? So I want to start with this. I'm going to date myself here. 1970s. Who is that and what movie? Yeah, old people are going, Matthew Broderick. Young people are going, who the hell's that? Okay. Old people, what movie? War Games. Old people, yeah. War Games. Alicia, when I was young, people said I looked like her.
Yes, I think you look like him. I said
Right? Okay. So, I want to play a game for 5 minutes that I think you should play a lot with kids that I think is very, very joyous. So, Amanda, you can help him. No, not you, that Amanda. Amanda, you know what we're playing. Amanda knows what we're playing. Okay? But the real question is, has Amanda figured out how to win? Oh, no. Okay, put that down. Sorry. Just get the eraser. Eraser. So I'm going to put up here 20 X's on 4. Okay? And I'm going to give all you a baggie of tiles in a second with 20 tiles. Or you can play it on the whiteboards that are at your tables. And you can write 20 X's. I think it's easier to play with manipulatives. 20 tiles in front of you. I'll give you a baggie in a second. So Amanda, here are the rules. Remember, right? You can erase 1X. You can erase 1X or 2X on your turn. And we're going to what? Take turns. Amanda wins $100 if she erases the last X. How many are you allowed to erase, Amanda? 1 or 2. How do you win the $100? You erase the last X. Go, Amanda. Amanda, we have all day here. 100 people are watching you right now. Someone's filming this for TikTok too. 1 or 2. You erase the last one. $100. 6 left. 3 left. That's the joyous moment right there! All right? I'll hand out towels in a second. You can play on your boards, but Abby, you gotta come up here. Come on, Abby. Abby said I wouldn't pick on her, so. All right. Abby, you got any ideas?
I want to go first.
Abby wants to go first. All right? Go, Abby. Dead silence here again, Abby. 3 left, Abby. Very joyous.
Oh, no. Come on.
Ah! See, Abby turned it into a joyous moment, but she cheated. Right. Now, I claim I've done this game in every grade, from kindergarten all the way up to my college kids. And there is joy. And why is there some joy here? Is because you totally understand what to do even if you're 6 years old, right? But you can't figure out how to what? Win yet. That moment is very hard to find in education. Because what happens in classes is you got the smart kids who do everything, know everything, bore out of their mind. And the other kids who can't do problem number 1. But here we have a sweet spot. And I call it a sweet spot, it's real joy. I can play a special ed kid against the smartest kid in the world, and they're kind of like even. They're just taking away 1s or 2s. Special ed kid can all of a sudden win because there's no formula you need to know. Just playing a game right now. There will be math coming up. You have 5 minutes to figure it out. If you want tiles, can someone help me, Albert, or someone? Okay. Yeah, you pass them out. Okay. Albert, pass them out. Again, you can do it on your boards. Just get 2 or 3. Okay.
I forgot it.
You want to do it. Do it. Okay. Wait, well, you gotta come up and beat me. I tried to hit you. There's 20 each baggie. There's 20 each baggie. When you're ready to challenge me, let me know. In front of 100 people when you're ready to challenge me. I did get beat once by a 3rd grader, the worst day of my life. Point Pleasant Borough, never forget it. Hey Lynn, you got any challenges for me at that table?
No, you don't. No. You go winner. Winner takes the last one. Yeah, you put it.
I got any challengers? Is she challenging? Oh, I'm a little nervous. All right, come on. All right, wait. She has very confidence about her. All right? I kind of feel like it's the price is right. What's your name? Aaron, would you like to spin the big wheel? Okay. But Sarah came right up at me. She says, what?
I want you to go first.
She wants me to go first. And I would say to Sarah, shouldn't it be beauty before age? No? So Sarah is insistent that I go first. You guys agree? All right, go Sarah. 3 left, Sarah. Joyous. Man, you can't lose again. I want this one over here. Name? I'm from Dover. I'm a little nervous. Dover. Aaron, I kind of recognize you. Alright. I think Aaron has seen me before. Might have seen this show before. Aaron is wasting no time. I quit. No. Alright. Aaron is a Rowan student. No? No. Oh, you just laughed. Shit. You see what she's doing there? See, what did she do there? Can you tell what she was doing there? She was counting. I am a very sore loser. Get back here. All right, tell the crowd, because we got to go on. Tell the crowd, what'd you do?
So you want to keep him at factors of 3.
Not factors.
Multiples of 3. So I have to go first so that I can get him to 18. And then I just have to maintain keeping him at groups of 3.
Very good job. If you want to play Aaron during lunch, if you don't quite understand. All right, where's my clicker? All right, so very joyous game, and I'm sure not everybody totally gets it yet. It's actually called NIM, okay? And when you download these slides, which I'll give you, you can see a link, and you can see directions. I don't like it played online. I like it played tactile, okay? All right, game number 2. There's a favorite kindergarten game, but it works just as well in 1st, 2nd, and 3rd grade. It's called 9 Squares. And your job is to take the numbers 1 through 9 only, and arrange them in this set where 5 are on the bottom and 4 on the top. But the bottom 2 that touch must add to the number on top. So if you look at the far left, remember you only have the numbers 1 through 9 once and only once. You put a 5 on the bottom and a 3 next to it, what must be on top? 8. Then if you put next to the 3 a 4, what must be on top? 7. And you must only use each number 1 through 9 once and only once. If you try to do this on paper and pencil, you'll be scribbling out forever. However, if you take the tiles I gave you and take a Sharpie or something and put the numbers 1 through 9 on them, you just turned it into a what? A tactile activity where you can move the numbers around. You want to be able to do it tactilely, not with pencil and paper, because you will have a hard time remembering what numbers you used or didn't use. If you just have one of each number on a tile, you can't repeat a number. Okay? This seems incredibly simple. I promise you it's not. You have 2 minutes. After we just say it's incredibly simple, I'll give you 2 minutes. You can write on the tiles, yes. You can write on them. You can write on them. You have 4 sets now if you have 2 baggies because there's 20 in each bag.
So we have to make sure that all the schools that are talking about this 5-9. This should be or I have so what the these 2 have to read? Oh, is that one? I thought it was a top.
right back here?
So the top,
Ah.
so the two tops have to answer.
Ah, I
So
see.
like this would be like a one and
Very
a two.
good. Very nice. He's going to answer in the back of the
This would be
room.
like one and two is a three.
Where's Aaron?
Oh, okay.
Oh, there you are. No answer this time? The answer in the back of the room, obviously, they did a great job, but there are many answers. Many answers. Here's two of them. Here's two of them. In the back. In the back. Do you have that box, Matthew? Yeah. Oh, you started over there.
Yeah, so like 7 plus 1 is 8.
Oh, Aaron wants to talk about this one too. Is that like in the mind?
I thought the sum number of the two numbers on the bottom. Oh, I thought they all equal 9. Alright, well that makes sense.
So there's two answers on the board. Aaron has another answer. Let me ask you, is it joyous? Is it a little bit of, dare I say, fun? Here's another one. Use your tiles again, make 3 fractions that are equal.
Oh, I love this.
Make 3 fractions that are equal. The second fraction has to have a double-digit denominator. The word joy just eliminated because I said fraction? Hard to do on paper. You don't use them all this time. You only use 7 of them. Well, a really good question is which 2 do you not use? We have an answer over here? Yeah, oh, okay. What do we got? 3/4, 9/12, 6/8. Excellent. Excellent. I'm going to give you all the answers. There are 3 of them. And I'd like you to look at these answers and tell me something. What do you notice? Yeah. The answer always starts with a 4th. And gosh, look at where the 9 always is. You would have never thought that in a million years. The 9 is always on the numerator of the double-digit guy. I have them kind of like switch the double-digit on the end. That's irrelevant. We can all deal with community problems, right? Fascinating that these are the only 3 answers. One more. Now, this is one of my favorites. You got to use all 9 of your numbers. You got to add 3 3-digit numbers. You can't go over 1,000. How close to 1,000 can you get? Kids are fascinated. How close to 1,000 can you get? Remember, you can't do 3, 3, 3. You only have 1, 3. How close to 1,000 can you get? This one, though, every one of you is going to use your phone as a calculator. And the question becomes, are you going to let your kids use a calculator? Anybody got over 900? How much is that? How much? Way over 900. Way over 1,000. Can't go over. How much is that? They got 900 exactly. No, you gotta get close to 1,000. You're over. You lose. Price is Right rules. Right now, 900 is the most. Anybody got more than 900? 972. Yeah, right. All right. If, right. I'm gonna trust them back here. They're pulling out the calculator. Okay. You really typed it in wrong. No, you're typing it in wrong. Okay. 981. How much? 999? She says she has 1,000. Is she lying? I think she is. Let me check. All right. Well, first of all, there's no way it's 1,000. That guy's up to 19. Yeah. Yeah. 999. Yes, 999 is the highest you can get. Okay, 999 is the highest you can get, which is completely different than yours, by the way. There are tons of different answers. Tons. But 999 is the highest you can get. All right? Don't do this one. Don't do this one. Just listen to me for a second. I want to do this one together. This one says, make a 4-digit number and subtract another 4-digit number, and then what's the smallest you can get? That's extremely difficult. So I say to kids, could we make an easier problem to start with? What could we start with instead of a 4-digit minus a 4-digit get the smallest answer? We start with what? 1 digit. If it was 1 digit minus 1 digit, okay, what's the smallest answer we could get? 1. A lot of different ways, right? Okay? Couldn't get 0 because you can't use a tile more than once. 3 minus 2, 9 minus 8, 7 minus 6, right? Okay? Now we go to what?
2.
What do you think the answer is if we do 2-digit minus 2-digit? Can we still get 1? 11, good. Anybody else? 31 minus what? 31 minus 29 gives me what? 2. 2. Wow. So your mind should start to be thinking now, oh, where the hell is he going? 3-digit type minus 3-digit is the answer. Well, I do know mine, but okay. I just have to click the clicker. Okay. All right. But what do you think? You think it is 3? See, it's almost like I don't want to tell you, but they're holding up signs back there. You only have a few minutes left. Okay? I want you to what? Explore that. Is it 3? And is a 4-digit minus a 4-digit what? 4. I hate giving it to you. The exploration of this subtraction problem is, to me, beautiful. Rather than a worksheet of 47 subtraction problems that bores the hell out of every kid. 1 digit minus 1 digit. 2-digit times 2-digit. You're ready now. You just got the answer of 2 for 2-digit minus 2-digit. What about 3-digit minus 3-digit? And the answer is 14. Which messes up all your intuition, right? And it's like, why is it 14? I'll tell you, I have no idea why, all right? But it's 14, 612 minus 598. And 4-digit minus 4-digit is 136. Why? I have no idea. But gosh, we're doing so much wonderful subtraction. But my point is, you cannot start here. You lose something there. You lose a beauty that I keep saying about mathematics, of being able to start there. and there. Look at it. And there, and there. Don't lose that beauty. Also, it's a nice scaffold. It's a nice scaffold. Starting with single-digit numbers and then double-digit and so on. Right. Lynn, you're getting all these. Stop taking pictures. All right? I'm required by law, all professors are, to show this slide in every presentation. It's a law. Okay? All right? It's a law. I must show it. Just in case the professor police came by, I did show Bloom's taxonomy. Okay? And I joke at that because it's been around forever, but I do think it's more prevalent than ever now because I visit hundreds of classrooms and all I see is we're still down at the damn bottom. We're still down at the damn bottom. All these exercises we've done today are at the top. Everything we're doing in this session so far, we are what? Creating problems. I didn't give you the numbers. You created the numbers. And we have to be there. So I'll end with one math problem that we still can't solve, that no mathematician in the whole world has solved, but yet it's a third grade problem. And I think it's wonderful one day to stand up in front of third graders and go, you know what, no one in the whole world has solved this problem, let's try it. And 9-year-olds will be like, yeah, we can do it. Yeah. Right? So here's a problem that no one in the whole world has solved. Pick any number, okay? Don't pick it right now, just we're gonna do it together, okay? If a number is even, you're gonna cut it in half. If it's odd, you're gonna triple it and add one, okay? So we'll do it together. If it's even, half. If it's odd, triple and add one. So we're gonna start with, and then we're gonna take the new number and do it again and again and again. It's called iterative. So it doesn't make much sense until we do it. Try 12. 12 becomes what? 6. 6 becomes 3. 3 becomes 5. 16, 8, 4, 2, 1. Third grade, all we did was take half, or divide by 2 if you don't want to say take half. And then times by 3 plus 1. 12 went to 6, 6 went to 3, 3 tripled, add 1 to 10, 10 half to 5, 5's odd, so we triple add 1, 16, half 16, 8, half 8, half 4, half 2, half 1. So this is what nobody in the history of mankind has ever figured out. Will every single number that you start with always end at what? And we have no idea. Computers have done it for a lot of numbers, but can computers do it for every number? No, they can't do it for every number in existence. Let's try another one. That's 19. So I gave you the damn answer here. 19 times 3. 57 plus 1, 58, half 29, triple plus 1, 88, and so on. And it goes down to what? 1. This one takes a while, right? It takes a while, but eventually gets there. Nice homework problem. Every kid gets a what? Every kid gets a different number. All right? Now, you might be careful a little bit with that. Because some numbers take what? Longer than others. So let's just try one more. Let's try 27. 27 becomes, help me. It's odd, triple and add 1. What is it? What? 8, I lost the screen up front. 82. 82 becomes 41. 41 becomes 1 what? 120, I can't walk this far back. 124. 124 becomes 62. 62 becomes 31. 31 becomes 94. 94 becomes 47. 47 becomes 142. 142 becomes, which kid you giving this number to? 71? 214? They gave me a sign for 10 minutes, they're way off. As soon as you get that odd, you have that ugly feeling. All right. This is complete joy to me. All right. Will it ever get there? They're cutting my side screens off even. Oh my God, we hit 4 digits. Oh, what are they doing to me? 668. Has anybody been counting? $7,288. How many clicks has this been? $9,232. Ah, you feel a little joy?
There we go.
If you know you have one of me in your 3rd grade class, you give me that one. I don't know if you could guess how many clicks that was. Anybody? It was over 100. Okay. There's a graph of it. Okay. It starts at 27. It does get a high of over 9,000. Comes back down to 1, and it was 111. It was 111 clicks to get it down to 1. 111 turns. We still have no idea in the whole world if every number will do this. This completely unsolved mystery available to all 3rd graders called the Collex conjecture. If we spent one day with just kids in our classroom doing different numbers, maybe making a poster or string, each number you write on a small piece of paper, you make a chain, you turn it into an art project. Be careful who you give 27 to. It will take 111 times. You can Google ahead of time how long will a number take in the Collex conjecture. So you can kind of put numbers out there to appropriate kids if you want. So someone kind of said as I was doing that, this is not joyous. And I say, oh, yes, it is. That is so much joy because you don't know. All the kids answer problems we give kids. Oh, the answer's 7, great. Great, the answer's 12, great. No, you don't know. I have a bunch of websites up here that you can play around with if you're bored doing the other presentations. Okay? All right? And you can download this whole PowerPoint at tinyurl.com/MiloJoy. Hey, thank you so much.